Vinegar is one of the oldest fermentation processes known to man. Apple cider vinegar is one of the most popular vinegar, famous for its medicinal properties and general health benefits. Apple cider dates back all the way back to around 2500 BC. An ancient tribe called the Aryans developed sword apple wine, which is the ACV's predecessor. From the Babylonians using vinegar to the Aryans and to the Phoenicians, the sword apple wine recipe had been passed to the Greeks and Romans, and since then, people started developing ACV as a byproduct to sword apple wine.
Which today, some uses of apple cider vinegar includes cleaning, food preservation, health, and improving skin function. It can also be used in all sorts of cuisine, including soups, sauces, hot drinks, salad dressings, and more. Hi, I'm Carmela.
Jules.
Sophie!
AJ!
And I'm Liam. And in this video, we will explain the science behind the production of apple cider vinegar. Making apple cider vinegar is a two-step bioprocess. There is the alcohol making process, which is anaerobic, meaning no oxygen is required. Then the actual vinegar making, which is aerobic, as oxygen is required.
The main process occurring here in the first step is the alcohol fermentation performed by the yeast, which is a unicellular member of the fungi kingdom, mainly the Saccharomyces species.
Sugars, particularly glucose, will be oxidized over the 10 steps on glycolysis to produce 2 pyruvate molecules and 2 ATP molecules, using 2 molecules of NAD+ in the process. Then each pyruvate will undergo decarboxylation, that is releasing carbon dioxide to produce acetaldehyde.
Acetaldehyde is reduced by NADH to produce ethanol. This allows for the regeneration of NAD+, which can be reused in glycolysis. The final product, ethanol, is a kind of alcohol that humans consume, hence the term alcoholic fermentation. And this process has been utilized for centuries to produce alcohol beverages such as beer and wine, as well as apple cider vinegar through this next process.
In the second stage, the ethanol produced in the alcohol fermentation will be oxidized in an aerobic process by acetic acid bacteria, or AAB for short, which is conventionally categorized into 2 major genera, Acetobacter and Gluconobacter, to form acetic acid, which is now our apple cider vinegar.
In the making of apple cider vinegar, the raw material we will be using would obviously be apple. First, for the alcohol making, we will need about 8 apples, which would also serve as our source of sugar.
We would also utilize the yeast, that is the fungi, that performs fermentation. Although yeast occurs naturally on the apples, it does not have the ability to convert enough sugar into high enough alcohol. Higher alcohol means better vinegar, so adding yeast would help on speeding up the fermentation at about a few hours later, and we would be seeing some action.
We'd also need more sugar. Though apple contains plenty of natural sugars, adding more sugar will sweeten the beverage and speed up fermentation.
Once we have our alcohol, we can proceed to the oxidation to acetic acid. Although acetic acid bacteria are present in the environment and in the raw material, it is important to directly add raw unfiltered apple cider vinegar as a starter culture where the AAB and mother is present to save some time, since it would take some time for the AAB in the environment to start working.
We should also prepare blender or juicer, different containers, one that can be closed and open, cheesecloth, and measuring spoon.
Now that you know the processes involved and the rationale of the ingredients and materials, we can now proceed to our actual demonstration on how to make drinking wine or apple cider vinegar.
First, we would want to cut the apple and juice them with a juicer or a blender. This is to extract and expose the natural sugars in apple.
Once done, transfer them to a container. Add yeast depending on how much juice you have. For this, we will be adding 1/2 teaspoon. This will cut the process from days to within 5 or 6 hours to see some actions, thus making the process faster, unlike resorting to the natural yeast.
Then, add white sugar. Just make sure right small amount is placed so that the conversion of sugar to alcohol by the yeast is not too strong or weak. Too weak in alcohol will not make vinegar. Too strong, the vinegar will be way too acidic and the base weight. In this case, apple will be gone and taste way too strong.
Since this is an anaerobic process, seal it tightly to prevent oxygen from entering. Once done, leave it to ferment for 3 to 6 days, giving it enough time for the sugar to convert to alcohol.
When the yeast has converted all the sugar to alcohol, we can now proceed to the vinegar making. First, separate the liquid from the sediments, which is just apple sludge and yeast, by opening the container and transferring the liquid in an open lid container. Be careful, since CO2 produced in the first process might cause a bursting reaction, since it has been wanting to come out the airtight container.
You can add the raw unfiltered apple cider vinegar where the AAB and mother is present to activate and start eating all the ethanol produced in the first step, making the process faster.
Since this will be an aerobic process, seal it just with a cheesecloth to allow the oxygen to come in and to allow acetic acid bacteria to grow while preventing fruit flies to enter. Place the product in a place out of direct sunlight and in room temperature and wait for a few days.
Over the course of about a week, a mat-like structure called the mother of vinegar will be present, indicating the conversion of ethanol to acetic acid, which makes vinegar. Pull out the mother of vinegar, which can still be used again as a starter culture, and then transfer the liquid to another container, separating it to the sediments that can be disregarded.
The liquid now will be the apple cider vinegar.
And you can now consume it for multiple purposes.
That's it for making apple cider vinegar.
We hope you learned something.